In many real-world problems, the features influence the target in combination, not isolation. This is one of the core lessons in machine learning the whole model building idea is built upon. Most of the time, it's combination of two or more features. For example, if we're taking house pricing and prediction of house pricing in the particular area, if we are taking into consideration only the location, we know that the location is beautiful, then our target, which is price prediction, to predict the price, we would assume that if the location is great, then it might be reasonable to say that, well, this house is going to be amazing and it's going to cost a lot. But there are dependencies that the sensible outcome is tied to. It would be useful for model for us to know that the house is this square feet, or the house has been refurbished in not very distant past, and all of this influence the predictive outcome. And this process is called feature interactions or nonlinear dependency. One of the most powerful lessons I've learned, if not the most powerful this week. Another thing I want to tell is when I was building, my project basically was about finding the quality of wine. And I had a data set of red wine and white wine. I decided at the beginning that I'm going to be working with red wine only for the time, because I didn't know how to basically work around the data so I can wrap the basically lines of code into functions and then find the basically predictions. I didn't know how to do that, so I decided I'm gonna go with red wine only, and now I nearly know by heart the whole ML workflow. You outline the goal of the project, you know what the target variable is, you know what you're trying to find. Then all you need to do is data cleaning and pre-processing. So this is the stage where you check for nulls, you are checking if the data is basically cleaned. If it's not cleaned, you're doing the cleaning. After I outlined the project and cleaned the data, I then started doing EDA. EDA has become the stage where I learned, I think, the most of the lessons during the past week. And the first one is visualizations. Visualizations is basically there are three graphs that I needed to know when I was doing all of that I learned. First one is histograms, and to think about histograms, what histogram is, it's you're looking for the hills in the data. You're looking how hilled that data is, where are the peaks, where are the lows, and what does that data represent. So you're looking for shape of the data. The way to remember histograms is it is about distribution of data. It's about the shape of data. So histogram, hist is like history of the whole like data, is you look at the data from the beginning to the very end, and you see the whole basically all the waves, how they're going up and down, up and down. Box plots are used to compare variables. So for example, if to imagine box, and everything that's inside the box are called outliers, and all these kind of boxes are, or box of one data, box of the second data, box of third data is compared, and you can see where outliers are, and you can basically take some notes from that. Heat map correlation is very important because it shows you how all the features are correlated to target variable. And if you set palette to, I don't remember the name, if it will show you either the range of colors from red to blue, and the more red the color is, the most heated the feature is, hence the most correlated it is with target variable. If it's basically blue, then it has no correlation with it. These are three, which is histograms, box plots, and we have heat map correlation. And these three at the stage of EDA are like, I think at this stage where in my case, when I need to basically, my goal now is to learn as much as possible information so I can just speak the language, I understand the whole industry, and I know what I'm doing better than vast majority. So for me, it's important to know basically all these quirky little things, and the EDA has been the stage that I didn't know really much about. And these three, basically histograms, box plots, and heat map correlations, they are three visuals that are needed, I think, at the stage of mine where I'm learning uh, to see and visualize the data. It helps a lot. By this time, I didn't know how to read them as much, but now I understand it a little better. Now, the evaluation stage of the machine learning workflow is the most time-consuming process in the whole pipeline and can only be found through a constant endeavor to tune the parameters. So in my case, I found it interesting that you can only, it is one thing to engineer all the features, it is one thing to clean, it is another thing to do EDA and graphs. But when it comes to building a model, which is the main thing I'm here for, that is going to be as efficient as possible, it's to my intrinsic question I've been asking myself the whole week as to why is it the most time consuming, and it actually it can play on your nerves because you're expecting one outcome and then it gives you absolutely another one. I've given myself an answer that it's not about running dot score parentheses and do something with it, but it's about finding the right metrics, precision, recall, F1 score, blah, 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 using the right model, cross-validating it. It's about iteratively compare performance. It's about ensuring that there is no data leakage, which is, in my case, has been one of the problems over these two past big projects that I've posted already on GitHub. Data leakage is when the model knows what it shouldn't know. And one way to avoid it is to always include pre-processing methods like scaling or imputing into cross-validation folds and do it within them. And this week has been hard for me in a sense of focus, as I've finished career path, and although I have a plan, what am I going to do in the next following months, a clear, well-structured plan, I have been distracted by many things, and you get excited by this thing and get disappointed with another thing. In my case, I want to become a machine learning expert, and I need to focus on machine learning, and the next stage, as I've already mentioned in the previous video, that it's going to be AutoML, automated machine learning. I know where I need to go. It's just I need to say no to many things around it. And if I can define focus, these words I've been hearing a lot recently, is focus is the amount of things you say no to. And as Steve Jobs said it perfectly about product development stage in Apple, I don't know which year was that, we're just as proud of the things that we did as of the things that we didn't do. And that's the thing that I've learned from machine learning workflow. The fact that I can do something doesn't mean that I should do that. And those words, we're just as proud of the things that we did as of the things that we didn't do, I think relate to me a lot now.